All right, we are starting a new unit and a new booklet. That means that, notice this booklet is for the second 6 weeks. The first booklet that we have finished had all your grades for the first 6 weeks, which means at this point, all your grades for the first 6 weeks are done, and your average for the first 6 weeks is set unless you have any missing stuff you need to take care of, any retests or anything you need to take care of. You're going to have to get that done before grades are due. So make sure you're talking to Miss Woodlock about your grades if you think you have any reason to be concerned about them. Go ahead and you can fill out your cover of your new book. Put your name at the top, of course, my name and Miss Woodlock's name, in the teacher name, and whatever your class period is. And as before, go ahead and write your table number in there. This booklet is for the second 6 weeks. Any of the material in here, any grades we take from it are going to go on the second 6 weeks. And again, I hope that you've taken the time to get some blue tape and tape your binding. Otherwise, your book will fall apart by the end of the 6 weeks. And because I know, again, some of you are curious, I'll go ahead and tell you this is the Reluctant Dragon. It's from some Disney shorts from decades ago. This is Toothless from How to Train Your Dragon. And these are Zack and Wheezy from Dragon Tales. I know it matters to some of you. It always matters to some of you. Okay, let's look at the inside of your front cover at your table of contents. Go ahead and fill in your table of contents with, these are your page numbers, and you can copy down information on these bottom sections. This should also be written in your first book, so you can copy it from your first book or from my screen right here. I will be back, or I should be back from maternity leave before you finish this book, so I did go ahead and put my email address in here. But until I get back, you should still, if you're going to email anybody, you should email Miss Woodlock. So I wrote both our email addresses on here. Again, for Remind info, Miss Woodlock may have something along those lines to give you. And for turnitin.com, we'll deal with that on a day where you need it. And remember, if you at any point need some extra help, there is an online chemistry textbook, and here's your login information. And we're going to be doing quite a bit of math in this book, and there are some equations you're going to eventually need at the bottom of this page here, so that's just a quick reference spot. Let's look at your first stamp page for this book. Go ahead and label it Unit 3. And today, again, unless something changed in the time since I've recorded this video, today should be the 22nd or the 25th, depending on if it's an A-day or a B-day. And your stamp for the day, I think, is going to end up being probably page 12? No, page 11. Probably. Miss Woodlock may change that, depending on how long you spend doing stuff today. And let's look at your calendar, moving ahead to page 5. Today, again, depending on if it's an A-day or a B-day, you're starting Unit 3. Your test for Unit 3, again, depending on if it's an A-day or a B-day, will either be on the 4th or the 5th. And as usual, there are 2 quizzes in this unit, and at the time of my recording this, I'm not positive which of these days the quizzes will fall on. but Miss Woodlock should be able to tell you that so you can label it. And let's push ahead to page 9 and get started. You are going to need a calculator today, not immediately right this second, but eventually today you will need a calculator. So if you need to pause the video at this time and grab one, you can do that. You will need a calculator today. And at this point, if you're playing the video, then everyone should have a calculator already. Let's talk about scientific notation. Like I said, this whole book, we're doing a lot of math. And we're going to start with something simple that you should already know. We're just going to review it. Scientific notation. You should have done this in like middle school and stuff. Maybe even elementary school. When numbers are too large, like 602200000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 that many atoms, or too small, like 0.00000000002309 meters, it's easier to write them in scientific notation using powers of 10 instead of having to write all of those zeros. So if you're starting in standard notation, that's like the normal way of writing a number, and you want to change to scientific notation, all you really end up doing is moving the decimal and then figuring out how many times you've moved it. So, for example, if you start with 324,170 as your standard notation, and you want to write it in scientific notation, what you do is you're always trying to make the number be between 1 and 10. You want it to be between 1 and 10. So you move the decimal point until you get a number that's between 1 and 10. So with 324,170, the decimal point, remember with a normal number, always is all the way over to the right. And we want to move it until we get a number between 1 and 10. So if I move it here, then I have 32,417. That's more than 10. I got to keep going. I move it again, and it would be 3,241.7. That's still more than 10. Move it again. 324, that's more than 10. Move it again. 32, more than 10. Move it again. 3.2, oh, that's between 1 and 10. So that's where I'm going to stop. If I kept going, then I'd have 0.3, which is less than 1, that has fallen right back out of my range. I don't want that. So I stop moving the decimal when it hits here. So then I rewrite the number 3.2417. You can drop any extra zeros. And this number here, 3.2417, is between 1 and 10, which is what I want. And then you count how many times you move the decimal. 1, 2, 3, 4, 5. So since we moved the decimal point 5 times, our exponent is going to be 5. So 10 to the 5th. And the reason it's a 5 right there is because we moved it 5 times. If you move the decimal to the left, then that's a positive exponent. The other way to look at it is if your starting number was bigger than 1, then you're going to get a positive exponent from that. We have another example over here where we're starting with 0.0000032 and we want to write that in scientific notation. So this one, the decimal point's written in for us. And again, we want to make this number be between 1 and 10. So if I were to move this decimal point like that way, I would keep making this number smaller and smaller and getting further and further away from our range of 1 and 10. That's not going to work. So we got to move it the other way this time. If I move it here, I get 0.00032. That's still too little. Move it again, 0.00032, still too little. Move it again, 0.0032, 0.032, 0.32. Oh, 3.2. If I move it here, that is between 1 and 10, so that's where I'm going to move my decimal to. That gives me this little front number, becomes 3.2. That is between 1 and 10, which is what we want. And then we count how many times we moved it. 1, 2, 3, 4, 5, 6. So our exponent is a 6 because we moved it 6 times. But our exponent here ends up being negative because we moved our decimal to the right. You could also say that the starting number was less than 1. And that's how we get a negative exponent. So when the starting number is bigger than 1, you're going to have a positive exponent. If your starting number is less than 1, you're going to have a negative exponent. So it wasn't just 6, it was negative 6 for our exponent here. You can also go backward. If you're given 5.21236 times 10 to the 5th in standard notation, and they want you to take the scientific notation, write it in standard, so write it like a normal number. That means you look at that exponent and decide how many times you are supposed to move the decimal point. And again, a positive exponent, you could move it to the right, or you could say your number needs to be, you need to make your number bigger than 1. Oops, sorry, there you go. If it were a negative exponent, you would need to make your number less than 1. Remember, a positive exponent, it should be bigger than 1. A negative exponent, it should become less than 1. So since this was a positive exponent, we need our final number to be bigger than 1. So if I moved it this way, I'd be making it 0.5. That's smaller than 1. That's not good. So I got to make it bigger instead. And I move it this way 1, 2, 3, 4, 5 times. The new decimal lands here, which means my final number is 521,236. It's not so bad. I'm going to go ahead and do 2 more with you in this chart, and then you're going to practice real quick and fill out the chart yourself and make sure you're doing it correctly, and Miss Woodlock can check it for you, or put up the answers so you can check yourselves. But I'll do 1 more with you real quick. So 1 more of each, I should say. So I want to look at this one, 0.00325. If I want to write it in scientific notation, I know I'm going to be something times 10 to some power. Scientific notation is always a coefficient times 10 to some exponent. And I want my coefficient to be a number between 1 and 10. So I've got to move this decimal point. If I move it this way, and this way, this way, this way, I'm going to keep getting a number that's smaller and smaller, getting further away from my range of 1 and 10. So I can't move it that way. That's a bad idea. I should move it the other way. 1, 2, 3. If I move it 3 times, then I get 3.25 for my coefficient, that is a number between 1 and 10. That's when I stop moving the decimal. And because I moved it 3 times, 1, 2, 3, my exponent's going to be a 3. And I also have to decide, is this exponent going to be positive or negative? My starting number was less than 1, 0.00325, that is less than 1. And when my starting number is less than 1, I should have a negative exponent. So I'm going to make this negative. Okay, I'm going to do one more with you. Let's look at this problem. They give us scientific notation. I notice there is a negative exponent, which means I have to move the decimal to where my number gets smaller. I have to make it less than 1 when it's a negative exponent. If I moved the decimal this way, I would be getting bigger, 68, 684. That's bigger than 1. I don't want to do that. A negative exponent means I need to make it less than 1. So I'm going to move 1 to this way. And this empty spot here, I just stick a 0 in it, so that my final answer is 0.068402. Not so bad. You can pause the video and finish this chart. And Ms. Woodlock can double check your answers. All right, and if you're playing the video now, let's move on to page 10, which looks like this. When you calculate things like in a calculator, there are many ways to enter quantities in scientific notation in your calculator. We're going to use a method that replaces that times 10 and like the exponent button with just the letter E. And the reason we use this method is because you don't have to worry about typing in parentheses in your calculator if you use the E instead. So we're always going to use the E. So on your calculator, find the second button, and then there's a button labeled EE. It's right above the comma. So if you press second and then comma on your calculator, that'll pull up this EE. The EE stands for engineering exponent, because this is the way that engineers usually type stuff in their own calculators. And basically, if you press that E button, then you only have to type the exponent itself after that, and you get to save yourself a lot of typing. You don't have to worry about, you basically get to type fewer buttons, and you don't have to worry about parentheses ever. So it's very advantageous. You're going to use this E button. So on paper, if your calculator, or if your scientific notation says 8.73 times 10 to the negative 4, when you type that in your calculator, instead of typing this times 10 and hitting the exponent button, you just type the E instead. So this like times 10 and then that little like carety button that means exponent, you don't have to hit any of those. You just hit second comma to get this E. They mean the same thing. And so after the E, you can just type negative 4, which is what your exponent is. This E stands for exponent. It's saying now just type your exponent. So it should look like this in your calculator, 8.73 E negative 4. Or 4.302 times 10 to the 9th, instead of the times 10 and hitting that little exponent button, you just get that E in there. 4.302, this E stands for exponent, my exponent's 9, that's all you have to type. What you should not do in your calculator, 8.73 times 10 to like carety button to get to the negative 4th power, don't do that, okay? Because your calculator just changes it to have the E in it anyway. And if you type it like this, or 4.302 times 10 caret 9, if you type it like that, you have to worry about making sure you put parentheses in the right places when you do calculations, otherwise your calculator is going to give you the wrong answer, so don't do that. You do not want it to look like this. Okay, and another thing we see people doing a lot is they think you type 8.73 times 10, then the E, then -4. But the point of the E is that you don't have to write this times 10 anymore. The point of the E is you can just hit your coefficient, E, and then E stands for exponent, so then just type your exponent. So you're typing extra. We're teaching you a calculator shortcut here. If you're still typing the times 10, you're typing extra, and you'll notice it'll give you a wrong answer if you do that. Instead of 8.73 times 10 to the -4th, it will calculate that as times 10 to the -3rd. So be careful, make sure you're typing it exactly like this, where you type coefficient, E, exponent. That's what it should always be. It should be whatever the coefficient is. Then you have the E button, and then you type whatever your exponent is. That's all you should be typing for this. Okay, let's talk about rounding. In this class, we're always going to round to 2 decimal places, the hundredths place, with one exception. If the first 2 decimal places are zeros, you should just round to whatever the next place is. So if it's 0.004367, normally we round to the hundredths place, but if those are both zeros, don't just report your answer as 0. Just go to whatever the next thing that's not a 0 is and round there. So 0.004367 becomes 0.004. Remember that if the next digit over is 1, 2, 3, or 4, you round down. If it's 5, 6, 7, 8, or 9, you round up. So 1.43278, we round to the hundredths place, and that 2 would tell you to round down to just 1.43. But if it were 1.43578, we round to the hundredths place, that 5 tells you to round up. Instead of 1.43, you round to 1.44. In scientific notation, you round the coefficient just like any other number, and then you make sure that you, on your paper, write times 10 exponent after the rounded number. So like 5.388888889 E -26. The 5.38 here is your coefficient. There's an 8 after it telling us to round up. So 5.38 becomes 5.39. Then this E to the -26, that tells me, remember E is your exponent of 10, so that's times 10 to the -26. And you have to write it all together, 5.39 times 10 to the -26. So make sure you always look toward the end of your calculator and see if they put an E there. Because if so, you have to write something in scientific notation as your answer. All right, next page is page 11. This is your practice page that you should be doing for a stamp. My guess is that based on the time, there will be another video that you watched today. And Miss Woodlock, therefore, might change my stamp plans, which is totally fine. So either way, at this point, you have a little bit of time to work on this. And I'll pass it over to Miss Woodlock, and you'll be watching at least one other video today.